Okay, today we're doing lesson 1-4. As you can see, we're going to be writing linear equations. And let's just get started. You see my standards and objectives that we're going to be covering today. And let me give you some examples that hopefully correspond to your homework and help you with those problems. So here's an example. Write an equation in slope-intercept form for the line described. So in case you don't remember, I'm sure you do, but slope-intercept form looks like this: y equals mx plus b, where m represents the slope and b represents the y-intercept, where the line's going to cross the y-axis. Well, this problem in particular is kind of easy because they tell us the slope, they tell us m, and they also tell us the y-intercept, because you can see that this point 0,4 actually falls on the y-axis. So we know that m in this case is 4/3, and by virtue of the fact they gave us this ordered pair, we know that b is 4. And so, pretty simple. There's our answer for letter A. Well, what about when they don't give us the y-intercept in ordered pair form? How do we come up with b? How do we come up with the y-intercept? Well, in this case, we're given a point that the line goes through, and we know that the 5 is the x-coordinate and -2 is the y. Again, slope represents the m. So basically, you can see that we're given everything for the equation except for b. So we're going to use these numbers. We're going to substitute for y, m, and x in order to solve for b. So y is -2. Equals m, that's -3/5, times x, that's +5, plus b. Multiplying -3/5 times 5, the 5's would cancel, that leaves you with -3 plus b. Adding 3 to both sides, we get b is 1. And so putting our answer in slope-intercept form, we have y equals -3/5 x plus 1. And that's the answer for example 1b. Okay, here's another example of a problem where we are not given the slope. We're given 2 points on a line, so we're going to have to find the slope by using our slope formula. So that means y2 minus y1 over x2 minus x1, and -1 minus 11 is -12, -6 plus 9 is 3, and slope is -4. And now we pick one of these points. It really doesn't matter which one we pick to plug in for x and y. So I'll just go with the first one. You would be okay if you used the second one. Y equals mx, and we'll solve for b. 11 equals 36 plus b. Subtract 36 from both sides, and we get b is -25. So our final answer in slope-intercept form is y equals -4x minus 25. Okay, this one is a similar problem. It's just that we know the y-intercept. We just don't know the slope, so we can find the slope, and then we can use -6 as the y-intercept. So 10 minus -6 divided by -4 minus 0. 16 divided by -4 is -4. So that's the slope. And again, the point 0, -6 represents the y-intercept, that's b. So our answer is going to be y equals -4x minus 6. Okay, let's talk about equations of lines that are either parallel or perpendicular to other lines. And we just have to remember something that we were taught way back in Algebra 1, that two lines that are parallel have the same slope. They have different y-intercepts, but they have identical slopes. So for the line that I'm given in this problem, the slope of that line is 7/8. So when I write the equation for this line that passes through 4, -10, I'm going to use the same slope because I'm told that these are parallel. So here we go. Y equals mx plus b. We'll just go ahead and plug in. In this case, y is going to be -10. Slope is 7/8. X is 4. And we're going to solve for b. -10 equals 28/8 plus b. I can reduce 28/8 because 4 goes into both. 7/2 plus b. And I'm going to change -10 into halves to have a common denominator. So -10 is the same thing as -20 halves, -20/2. Now they have the same denominator. And now I can subtract, and I can actually put these two fractions together. So when I subtract 7 halves from both sides, I get -27 halves is equal to b. So using m as 7/8, and there's my b. Here is my final answer, 7/8 x minus 27 halves. All right, so there's an example of what to do when two lines are parallel regarding slope. And now what do we do when two lines are perpendicular? What do we know about their slopes? Well, the slopes of perpendicular lines, you may recall, they are opposite reciprocals of each other. So I take the slope of the given line, which is -5/3, and to write the line perpendicular to that, I'm going to use a slope of +3/5. Opposite reciprocal. And the process is really the same from that point on. We use our point that this line goes through. Y equals m, which is going to be 3/5, x, which is -9, and we're going to solve for b. Okay, so let's go ahead and simplify this. -3 is -27/5 plus b. I'm going to change -3 into fifths. It's -15/5. So that we can have a common denominator. So I just made -3 become -15/5. And I'm going to add 27/5 to both sides. And that leaves me with 12/5 for b. And then my answer, slope-intercept form, is going to be y equals 3/5 x plus 12/5. Okay, so those are some examples of problems that you're going to be doing in this assignment. And then I wanted to set you up to a certain point on this and then see if you can take it the rest of the way. Here's this number 30 word problem. And just reading it out, the sales of a sandwich store increased approximately linearly. So that's a clue that we're going to be writing a linear model. So just think y equals mx plus b is what we're headed towards, that kind of equation. Okay, what else do we know? Sales increased from 52,000 to 116,000 during the first 5 years of business. So we're supposed to write a linear equation that models the sales. Sales will be y, and x represents a number of years that have passed. Okay, so in word problems like this, let's think about how we can, this kind of ties into what we did in the previous lesson when we talked about rate of change. Let's think about this. In year one, it says in the first 5 years of business. So think about it like this. In the first year, we had sales of 52,000. So if we were doing a graph, for example, we typically have time on the x-axis, and in this case we would have sales. So 1 year, after 1 year, sales would be 52,000. And we're told that they increase. So at the end of 5 years, they are 116,000. Okay, so if we can come up with a couple of ordered pairs, then we pretty much have this problem licked because we know how to find the slope given 2 ordered pairs. I just wanted to show you how we could use the information that's given to come up with ordered pairs that represent this data. And now I want to see if you can take it from there. So just use your slope formula and then choose either one of these once you've found the slope to plug in for x and y, and you're going to need to solve for b. So doing just exactly like you did on the previous problems, except this is a real life situation. Okay, so I hope that gives you enough. I just wanted to set it up, and then I wanted to see if you could take it from there. Find the slope, plug that number in for m, use one of these points for x and y, just like you did on the previous problem, and then solve for b. So you're going to give me really 2 answers. What is the equation that models this? So you're going to give me the y equals mx plus b that models this situation, and then use that equation to tell me what the sales would be at the end of 12 years. Remember, x represents the number of years. All right, so 2-part answer. How much sales? Okay, so I hope that helps. You can check RenWeb for the assignment. If you have any questions about any of these problems as you're working on them, please let me know.